Well, good evening, good afternoon. So today we are going to discuss about another important topic, which is important for the both the sides of the people, both SRF, JRF, both of you have this syllabus. It's a very common syllabus. This is called Soils of India. So we know India is a very diversified country. We have a different climatic zones. We have a different rainfall situation is prevailing in entire India. So the variability is very high from north to south. So like that, we have a different soils. So what are those soils? What are the characteristics and how far it was distributed throughout the country? We're going to discuss today. And very first, very important soil is alluvial soils. Alluvial means it's completely it's a soil have very well developed soils. It is completely developed soils, and also it's a very fertile agriculture land, which is of course almost around. It is all these alluvial soils are completely you can see only besides the river streams. Because all the river deposits are called as alluvial soils. So mostly these are a very well fertile soils in agriculture land. Almost it occupies around 50 million hectares in Indo-Gangetic plains and at the Brahmaputra Valley, and these soils are highly way it was distributed throughout the country. You can see in Punjab, Haryana, Uttar Pradesh, Madhya Pradesh, Assam, Bihar, West Bengal, and coastal regions of Odisha, Tamil Nadu, Kerala, and Gujarat. So overall, students, wherever the river streams are there we can see the alluvial soils. And parent material. How far these parent materials are there? Because mostly these pyramid is nothing but erosion products. So erosion products of the river systems. So mostly these are by all these deposits. These are the alluvial deposits are completely came from the river laid by down by the numerous river systems. So all these river deposits are the source of parent material for this type of soils. So mostly you can see in there are different type of alluvials. You can see coastal alluvium. Mostly you can see in sea currents. So whatever the deposits are come from the sea currents or coast are called the coastal alluvium. It is completely laid by the sea currents. And another what are the major characteristics of these alluvial soils? You should know those characteristics. What are those characteristics? Mostly the color dependent, completely current. The parent the general dependent current material depend upon the color source of the parent material and calcareous. So color is completely depend upon the source of the parent material with the calcareous, so the calcium deposits. Texture varies from very coarse to fine student. So the texture is varies from very coarse to fine. In general speaking, fine textures of alluvium the better for the soil conditions. So fine texture of alluvial soils are very well fertile, where are the better soil conditions for the plant growth. So what is the development of profiles, sir? So mostly we can see a very some we can say some underdeveloped profile because it's a complete developed mostly A and C profile where some or sometimes you can see and BT. What is a BT? BT means you can see some clay deposits also so profiles. So they are these soils are naturally these are came from the river deposits. So naturally these soils are very rich in plant nutrition and with a sufficient amount of phosphorus and well supplied potassium. But you can see some deficit in nitrogen and organic matter content. So these are river deposits. These alluvials are completely river deposits from the various rivers of India. So you can't find much profile development. Hardly you can see A and C, or you can say to vary from underdevelopment to up to you can see A and BT organic. So you can say from underdevelopment profile to developed profile up to A or B, C. If you want to see very specific, you can see profile BT. So mostly these are all alkaline in reaction students, but maybe in acidic. Sometimes the most of these alluvial deposits are alkaline in reaction, but there are some acidic reactions also you can see in Assam, Odisha, where the rainfall is quite high. Especially students in Odisha, most of the soils in Odisha, 80% of Odisha soils are acidic soil regions. But there also one river is there, Mahanadi River is there. But there in that condition of there also you can get some alluvial texture conditions you can see. But due to the heavy rainfall systems, what will happen? All the bases will be leached out, so naturally the soil will become acidic condition. This is one type of character. And classification students. Naturally, these soils are mostly in which classes you can see. You can see NT soils because deposits. NT soils always you can see deposits. Incepti soils you can see. Even you can see an alpha soil, yeah, or even you can found in RD soils also, as per the soil taxonomy. But what are the uses? Ultimately, what are the uses of this particular soils? We can grow very good for agricultural crops, especially wheat, rice, maize, groundnut, and besan. This one crop besan, so we can cultivate very good amount of, because these are inherently, these soils are well fertile, though it has a good amount of phosphorus and potassium, but a slight, we can see some problem with nitrogen and organic matter deficit because of indigenous. Yeah, this is what's true. This point you remember, these are indigenous irrigation water, because this completely used, indigenous means all the soils are come from the rivers, so naturally there is a water, there is no scarcity of water. And so soils have rendered waterlogged, there is some water pose a problem of soil salinity and sodicity. So naturally, due to these waterlogged conditions, there is some sort of a slight salinity problem also we can face. So these are the some sort of best uses of the classification of soils. Regarding the alluvial soils. And next is black soil, students. Black soils. So all of a sudden, black soils means we can say black cotton soils. Naturally, we will get in our mind, which can be always, we can see some cracks during the summertime, when there is a no lack of rainfall. You can some summer times we can see there is a churning, such churning, perturbations we can see in this type of soils. So mostly you can see where you can see Deccan Trap. Deccan Trap means our southern region, especially this Deccan Plateau area, especially this Telangana and some part of Maharashtra, a part of Karnataka borders. All this area you can see this part of it, and also you can see there some arid, semi-arid, and subhumid climatic conditions under grassy vegetations. We can see under grassy vegetations. These are called as black cotton soils. So mostly, students, this color, this black color, can be comparable with the Chernon gems of Russian, and the partial soils of cotton grown area of USA. But the physical chemical properties of this and these soils, this black cotton is also completely different. So mostly these type of soils are called as Rigrin in central area is the local name, and Karail in lower Gangetic basic plain of Uttar Pradesh, and Bhalin in Gujarat. So these are the some local vernacular names of this particular soil, this black cotton soils. So what are the distributions, from where these soils are distributed? These soils are commonly observed, we can see in Maharashtra, especially you can see Maharashtra, and western parts of the Madhya Pradesh. You can see in Gujarat and some parts of Andhra Pradesh and Tamil Nadu also you can see. Overall, students, in India, it was occupied around 54 million hectares. We can see this type of black cotton soils or black soils we can see. So parent material, students, what are the major parent material? These are the parent material come from Deccan Rajmal trap, that is volcanic rocks. So all the volcanic rocks such as basalt and other metamorphic rocks are major parent materials. Two types of parent material. This is one type of Deccan basalt and metamorphic rock. Another one called Gangetic in nearby Ganga Nadi. Genesis Gangetic genus Nissus and cyst containing lime and soda lime feldspars, which are the basic characters. So these are the two different parent material for the black cotton soils. And what type of vegetation you can expect in this type of soils? Mostly deciduous and tropical thorny forest with a very dense grown of grasses. You can see tropical thorny forest with a very dense grown grasses. You can see this type of vegetation in black cotton soils. The soils, what is the soil? The soils are completely developed on nis and cyst, which are moderately shallow. Around, we can see we develop around, we can see shallow around 50 to 80 centimeters. You can see, or moderately deep around 180 to 120 centimeters deep of development. You can see, while the soils which are developed on basalt, you can see very deep. It is 150 centimeters. Nis and cyst, you can see this type of, these are the centimeters development. But in basalt, it is very deep. It is more than 150 centimeters. They have a uniform color throughout the depth of 2 to 3 meters. Yes, students. So color will not be, there will be no change up to 3 centimeters, up to 2 to 3 centimeters. You can see there in profile, there will be no change in color. And you can see argillaceous particles as of smaller part. This argillin is one type of material. We can see smaller than 0.6 mm with the diameter, and clay content varies from 30 to 80 percentage. You can see more clay we can expect in this type. So mostly clay is dominantly mostly smithsite in nature and high coefficient with expansion contraction. This is the reason why the cracks we can see, and setting up study and churning process, which I said, the churn, mixing. That mixing process you can see within the pedon because of expansion, contraction, all this condition, all this will take place in this type of soils. So coming to the student, these are the process of churning causes vertical mixturing of later development of typical features. So student, the turbation, that mixing of soils, especially in this type of this type of black soils, you can see that mixing whenever there is no moisture, you can see big cracks like this. You can see the big cracks you can see. But whenever the moisture came or when the water comes, what happened? Automatically it will contract and the soil will become close. So during this period of time, what will happen? There will be mixing of layers. The horizons or layers will be mixing. During this process, we can see some three different features. We can see what are those? Gilgay micro relief. You can see some micro relief. There will be a wide cracks. You can see, and also closely intersecting silken sites. You can see some silken sites. You can, so these are the three different characteristics we can identify in the black cotton soil. So remember students, so these are typical characters for the black cotton soils. What are the Gilgay micro relief, wide deep cracks, and closely intersecting silken sites we can observe. And next to the crack, see, so we are getting, so crack sometimes you can see more than 1 centimeters wide and up to depth of 1 meter you can see, up to 1 meter you can see, and intersecting silken sites. So, silken sites and membrane and members having developed on calcareous parent material, which has most calcium carbonate content increases by the irregular depth, irregularly with depth. So what whenever this style soils are developed on any calcareous and any calcium content material, you can see some you can see some calcium deposits, so calcium carbonate in with the irregular development. So being a calcareous, the pH value where it will be around 7 to 8 to 9 up to here will be the CEC will be around 35 to 55 milliequivalents per 100 grams. It has high moisture holding capacity, but is not available to the plant because of fine texture. It has a high moisture capacity, but plants cannot use that one because of high fine texture. So black cotton soils of these soils due to the clay humus complex or the presence of titanium ferrous mineral, not due to the organic matter. So the black color students. Actually, this question came in I think this question is frequently asked. The black color of the black cotton soils is due to because of this titanium ferrous magnetite mineral. So this is the reason. Please note down. Due to this material, this particular soils will looks for the black color. So titanium ferrous magnetite are the reason why the black soil looks like black color. So classification students, mostly you can see vertisols, very interesting. Whenever you see black cotton soils, immediately we should strike out with the vertisols. And sometimes we can identify sometimes some shallow soils, sometimes some shallow soils. Sometimes you can see that antisols and inseptisols, depending upon the profile development. Some profile development, if there is any clay accumulation, we can see in this type of soils also. What are the main characteristics, students, of crop production? It has a vertisolar and it is workability. No, whenever this black cotton soil is very difficult. Even we can't pull. Which is working in black cotton soil is very difficult because of how holding is very high and infiltration was very less, and there will be poor drainage and moisture stress was very occasionally. You can see some moisture stress. So these are some sort of problems in this black cotton soils. And these are predominantly cotton growing students. Cotton, we can grow cotton in this type of soils. We can grow cotton. We can grow millets. We can grow sorghum. Mostly in Madhya Pradesh and Andhra Pradesh and Gujarat and Maharashtra, you can see this type of conditions: cotton, millet, sorghum. You can see all this type of growing conditions in this type of cotton soils. Another one is called red soils. No, red soils. These are sorry, red soils mostly where these are the formed mostly from granite and gist and cyst under subtropical conditions. You can see this type of it's a very deep, well drained. The soils are well drained with a clay enriched. It's completely developed from granite and gneiss and cyst. You can see conditions mostly where we can see under southern peninsular conditions, especially in Tamil Nadu. You can see this type of soils, red soils in Karnataka, Maharashtra, and East Andhra Pradesh, especially in my area, especially in my region of this southern Prakasham and some part of Guntur districts. We can see this type of Andhra Pradesh. We can see some sort of this red soils. We can see in Madhya Pradesh, Goa, Puducherry, Odisha also. Yeah, in Odisha also we can expect some red soils. And and also it is occasionally observed in north somewhere in Bihar, West Bengal, Assam, and Uttar Pradesh also we can see. There occasionally these often occur in association with true laterites. So sometimes this type of soils we can see with the association of laterites also. Mostly in Andhra Pradesh and Madhya Pradesh and Karnataka, red and black soils occur side by side. Especially students. Yeah, I have seen in Andhra Pradesh. You can see red soils immediately after a few distance. Immediately we can see black soils also. So they can see side by side. The red soils occupy mostly topographic positions. In higher topography positions, we can see red soils, while the black cotton soils occupy the lower one. So where low in lower topography, you can see black cotton soils. In higher topography, you can see red soils. They are overall in India. It was estimated that 55 million hectares it was distributed. Overall, these red soils were distributed. These are these are, this is the distribution. So they remember, students, these are the points developed on granite and gypsum and the cyst. They're sometimes associated with the true laterites, and these are the few states which are distributed around 55 million hectares. We can see, especially in higher topographic positions, we can see red soils, and lower topographic positions we can see black soil. So these are some explanation of red soil. So what is the parent material? Yeah, we already, I'm starting itself, I'm saying granite and metamorphic rocks such as this and cyst. You can see mainly in Aki, this one period, students, geological pedology, this some geological period. Occasionally red soils are developed on micaceous cyst and sandstone also, and sandstone and shales we can see. But remember, yeah, these are the thing. Granite and gypsum cyst are the parent material for the red soils. So what are the conditions? What are the properties of these red soils? Red soils are grade from poor to thin gravel light texture. See how much vein they have given. So soil grades are from poor, thin, gravelly, and light textured soils. Light textured soils of the upland and much more fertile. Yeah, deep dark colors of soils of plains we can observe. So morphologically, red soils can be divided into two broad groups, students. Morphologically, by appearancely, we can see two broad groups. What are those? Red loam. Red loam means you can see argillinious particles, argillineous by the material, students. We can say around 0.06 millimeters diameter, clay enriched profile you can see with a cloudy structure and presence of only few congregations we can see. And red earths, mostly sesquio oxide, students, especially rich in concentration of sesquio oxide. In red earth you can see this type of condition. Red earth, mostly these are rich in sesquio oxides, iron aluminum oxides are very rich in red earth. These are the two characteristics, red loam and red earths. And major characteristics, color. Why is red color to red to yellow? Because of coating of ferrous oxides. Anyone can say. This is a very fundamental question. What is the reason of red color? Because of ferric oxides. Mostly ferric oxides, hematite, mostly oranohydrated ferric oxides, yellow when ferric oxides occur hydrated, mostly limonite. If the condition is and yellow when the ferric oxide occur, it's a limonite region. So texture we can say loamy to clay texture you can expect. What is the depth? There are very shallow depth, students. The grade is poor, thin, gravelly in upland to fertile, deep in plains vertically, and texture is comparatively fine. And generally it will be very low. So overall, the silica sesquio oxide ratio is around 2.5 to 3. So this is the ratio between silica and sesquio oxides. But the amount of iron aluminum is generally very high in this type of soils. Naturally, in red soils, iron aluminum, the sesquio oxides is very high. That's the main reason why the soils looks are very red in color. 30 to 40% you can expect. So silica and sesquio oxide ratio is 2.5 to 3. So these are the reasons. The CEC and base saturation of these soils are very low, but have very high values than laterite soils. But the red soils, it was very low. But when you compare with laterite soils, definitely the CEC and base saturation is very high. These soils are completely deficient in nitrogen, phosphorus, but are well supplied with potassium. See, students, these red soils are poor in nitrogen, phosphorus, but are good in potassium, and also poor in organic matter and lime content. So lime content and organic content was very less. Especially in Bhubaneswar, we can see this type of conditions. Completely red soils, there is no organic matter, no lime content, fully acidic, hardly you can see 4. The pH will be recorded as 4. So immediately everyone will go for recommendation of lime to overcome the acidic problem, and also to uplift the uptake of nitrogen and phosphorus and other important nutrients for the plant growth. So classification, mostly red soils we can say alpes and alti soils. This is the reason. What are the uses? So soils are cultivated intensively for a large variety of crops. We can grow paddy, we can go for paddy, tea crop also we can grow, tea, coffee and cardamom and many other field crops under heavy doses of organic manure and artificial fertilizer under the irrigation conditions. So in red soil, students, due to this iron aluminum problem, you know, management of fertility is very difficult. So we have to give very artificially. Most of time they will give a foliar application. So generally, whenever you found this, if the condition was very severe, if there is a very high amount of this, you know, this sesquio oxides, then we have to go for foliar applications. We have to go for foliar applications. So we can go for paddy and tea crop. These are the conditions we can. So we need to go for artificial fertilizers under the irrigation conditions. This is the some sort of uses of this particular red soils. And another one is called laterite and lateritic soils. So lateritic soils, mostly this term laterite was coined by the Buchan in 1807 for highly ferruginous vesicular appearly under unsatisfied deposits, mostly observed in Malabar hills of India. And these laterites are mostly not useful for agriculture purpose. These are mostly formed in alternative wet and dry conditions. So under monsoon conditions, climatic conditions, basic parent rock and silicaceous material you can see leads to almost completely weathered. So overall, students, you know what is meaning of laterite. What is the meaning of laterization? Can anyone answer? What is the laterization? What is the laterization?
Accumulation of sesquiacids and removal of silica, sir.
Yeah, that is what's happening. That is what I'm saying is, yeah, these are the rich in sesquioxes, devoid of bases and primary silicate minerals. This is what your expert, this is what your definition was satisfied with this slide. And also students, they are very hard and capable of hardening when exposed to dry. Especially these laterite bricks, nowadays no one is using, but in very olden days, especially the olden days during the very old collectorate buildings, even Odisha University, OEAT building, that compound was completely constructed by the laterite stone only. And also TNA main building also constructed by this brick only. So whenever this laterite was exposed to the open air, the atmospheric condition, what will happen? It will become very hard, and that hardness is useful for we can use for brick condition. So it's almost compact and vesicular rock like material composed of essential of mineral added oxides of aluminum and iron you can see, and small amount of magnesium oxides and titanium you can see. The well-developed laterites are mostly occurs in hilltops of plateau of Odisha. Yes, students, especially in Odisha, especially if you have any chance whenever you come to Bhubaneswar, there you can see, especially in the outskirts of Bhubaneswar, there is villages. Mostly, most of the villages compound was constructed by this laterite stone in Odisha. And Maharashtra, Malabar, West Bengal, Kerala, very famous for this. And Tamil Nadu, Assam, you can see this type of laterite. So laterites also mostly distributed around 24.8 million hectares. So you can expect this type of soils in entire country. What are the characteristics, students? So these are the reddish color, soil color, and maximum intensity is B horizon is very more deeply weathered soils, and having high clay content, which is not due to migration in the B horizon. So there is a clay content, but not due to the migration, but in situ alteration of weatherable material. So those clay accumulation B is not due to the migration, but some mineral alteration. Due to the mineral alteration only, we have get that accumulation of clay in B horizon. With the deep, there is a decreasing intensity of red color. If you check the profile of this, you can see that deep red color will be decrease and clay content. So there is a decrease in red color and clay content. Both you can see there is a decrease in red color and also clay content. So with the pronounced leaching, the lost bases and silica, which is relative accumulation of sesquio oxide. This is what the laterization taking place. So most of these soils are completely distinctly acidic. They're completely acidic nature because all are gone. Only sesquio oxides were left, or silica was gone. So that's why this type of soils are completely acidic in nature, acidic in reaction. So what are the limitations? Deficiency of phosphate, as the high phosphorus fixation we can see because of more iron, aluminum. Acidity is more. As I said, aluminum, manganese is very high. Deficit in all major and macro and secondary nutrients like potassium, calcium, magnesium, zinc, boron. All type of nutrients are overall, student, this type of soils are not fit for the agriculture purpose. So students, remember there is a quite difference between laterite soils and lateritic soils. Please remember this. This is a sort of confusion. The typical laterites remain dry for around less than 2 months in a year. They will be dying. The soil remain dry for 4 to 5 months in a year. So in lateritic soils, you can say 4 to 5 months. The base saturation is less than 40% here in lateritic soils. The calcium carbonate, the CSF clay is around less than 6 milli equivalents per 100 grams. So here the base saturation is more than 40%. Sesquio oxides ratio is silicon aluminum oxides is less than 2. It is more than 2 here. The clay minerals, which is dominated by 1:1 type, most like ironite we can see. Here is a mixture of, we can see both the type, 1:1. The gypsite is generally absent here. Gypsite layer is completely absent here, but here, sorry, it is present here in laterite soils. It is absent in lateritic soils. So these are the quite difference between laterite and lateritic soils. The quite difference, but try to don't confuse. Many times people will just see these three first 2 4 letters and they will answer something and they will lose an exam. So don't go for this type of confusions here. So classification, mostly you can see alpine salts and oxy salts. We can see this type of laterite soils. So mostly sometimes we can go in this both. Only lateritic is suitable for the cultivation. We can grow for paddy, banana, and some occasion we can go for cashew nut. Mostly this type of baby plantations we can grow in this type of soils. So salt affected soils. Salt affected means is a completely which are mainly prone to this saline and alkali soils. So there is a separate chapters you will want to deal very separate about this type of soils. So this is a major problem, especially in Uttar Pradesh. Around you can see 1.3 million hectares in Gujarat, 1.2 million hectares in West Bengal, around zero point 0.8 million hectares in Rajasthan. So these are the overall 0.7. Rajasthan, Punjab is 0.7. Maharashtra, Haryana is 0.5. Odisha is 0.4. Karnataka also 0.4. And Andhra Pradesh is 0.04. And Madhya Pradesh is zero point 0.2 million hectares. So these are the list or some sort of statistics. So statistics we can't believe because we want to update the knowledge. So salt affected soil students, so majorly students, the accumulation of primarily of sodium and calcium magnesium as cations and chloride sulfates, which is nothing but the accumulation of secondary carbonates of calcium, magnesium, and sodium. So whenever the conditions are very high, the concentration of potassium carbonates, bicarbonates, and nitrates are comparatively low. So in the saline soils, mostly, this primary consisting of primarily of sodium and calcium, magnesium as cations, and chloride sulfates of ions. So you can expect this concentration of sodium and calcium and magnesium is very high. They are considered as cations, and chlorides and sulfates are very high. In counterpart, the concentration of potassium carbonates and bicarbonates of nitrates are comparatively very low. So mostly where you can see this type, you can solve some fluctuating depth of groundwater and water table. Sources of salt is often soils itself is a groundwater irrigation. So whenever we irrigate it with saline water, definitely soils will become saline, leads to turn into the salt affected soils, or fluctuating water table conditions we can see, and also soluble salts move from upward due to the water table raise. This is what happened in arid conditions. So whenever, see students, whenever how this happens means, especially if you think this is a land surface, this is a land surface, and in groundwater, in ground somewhere here in the water table is there. These are completely mixture of all this salts. Secondary all the sodium, calcium, magnesium, chlorides, and sulfates are all mixed in this, are dissolved in this soil. But there is no enough temperature was not there, so there is no enough rainfall. If there is enough rainfall, what will happen? The all the, that new that rainwater will be diluted all these salts, and this diluted water will be used for our day-to-day activity. But what will happen due to the evapotranspiration is very high? So due to the evapotranspiration is very high, what will happen? Due to the high evapotranspiration, due to the high temperatures are very high, what will happen? This water will be raised to the top layer. Due to the capillary action, this water will be raised here. So what will happen? All of a sudden, all this water come back to the upper layer. So what will happen? The water will be evaporated. The water will be go to the atmosphere. But what will happen? There will be accumulation of these salts. All the salts which are dissolved in this water will be accumulated in the top layer. Why? Because of all this water was evaporated due to evapotranspiration. This groundwater was raised and the water was evaporated, but dissolved salts can't evaporate. So they are all settled on this top layer. So ultimately, this entire land or the entire soils will become distinctly other completely salt affected. Although mostly this type of condition we can see in arid conditions, arid zones, you can see this type of problem. So mostly in arid zones, you can expect this type of problems. And all this is what I explained. And also in coastal areas, especially coastal area regions where the seawater, always intrusion of seawater is another reason due to the accumulation of some intruding seawater, especially wherever you can, mangrove forest. What is a mangrove forest? Anybody have idea? Mangrove forest? What is mangrove forest? No idea. What is a mangrove forest? Mangrove forest. You can see in Andhra Pradesh, you can see in Godavari districts, you can see, and even in Guntur, you can see. In Tamil Nadu, there's a coastal area. Actually, in vernacular name in Telugu, it's called Madadavalu. Those mangrove forests will stop the intrusion of seawater into the mainland. So they will act as a barrier. But nowadays, due to the illegal activities, what were happening? Those mangrove forests were destroyed. The mangrove forests were removed. What happening? The seawater is completely coming into the agricultural land. So what happened? Due the seawater is highly salt content was very high. What happened? They are depositing. They are come and depositing in the main agricultural land. What happening? Entire land is becoming acidic. Sorry, salty. So, all the salts were accumulated. Completely, those lands are unfit, coming as unfit for the agriculture purpose. So, due to the lack of that seawater intrusion, also is one reason, and also irrigation with high salt content water. So nowadays, what the farmers are doing? So they are putting deep well bores. So they are putting a bore. This bore, what happened? They're going for 400, 500 feet deep into the land. What happening? They are pulling the dissolved salts of water, salt affected water is there. So they are using that water for the irrigation purpose. What happening? Those salts are ultimately due to irrigation of that saline water. What happening? All those soils are completely becoming very distinctly acidic. Sorry, saline. They're completely becoming saline. All salts were accumulated. So these are the one reason. So major reason is sometimes there is inland, there is some natural source also is there. Student pyramid itself will act as a saline soil reason. That is one reason. Another reason is this cutting or chopping of this intrusion of the seawater, mostly in coastal area, especially coastal area of East Godavari, West Godavari, Andhra Pradesh, and also Kadalur and some parts of Tamil Nadu districts also, and also in Bengal also have this problem. There also intrusion of seawater is there. So whenever we due to the cut down of this mangrove forest, what happening? The seawater was completely coming into the agriculture land. What happening? It becoming all the agricultural lands are becoming saline soils because of seawater was introduced. This is one reason. Another reason irrigating with the saline water. So whenever we use saline salt water, for the saline water means the water which is dissolved with the carbonates of calcium, magnesium, and sodium, and chlorides and sulfates. Those are the cation anions. So when which concentration is very high, if we use that water, completely the soils will be becoming saline soils. These are the main properties of the salt affected soils. So this is the students. So what are the characteristic students? There will be the EC will be ECE means this is a saturation paste extractant value. Saturation paste extractant is one experiment is there, students. Saturation paste experiment. I will say after that. So ECE means it is around 4 decisiemens per meter. You should have, and exchangeable sodium percentage should be very less than 15, and pH will be less than 8.5, and the color will be grayish brown. Whenever you see that particular site will be grayish color, and you can see plateaued surface you can see, and blocky subsoil structure you can see. So these are the typical characteristics. Please note down. You will get definitely one question you may expect in the exam. These are students. So if it is a saline soil, the EC should be more than 4 decisiemens per meter. Exchangeable sodium should be less than 15. pH should be more than 8.5. Color should be grayish brown color, and plateaued surface. Blocky subsoil structure should be there. These are the saline soils having. So management of saline soils, how we have to go management soils? Generally, we have to go for, there's nothing, students. Very first, we have to go for tolerant crops. What are the tolerant crops, students? High salt tolerant crops. What are the Sesbania, rice, sugarcane, barley are the oats are the high salt tolerant crops. And another one is called another medium tolerant crops. So what are those? Castor, cotton, sodium, maize, mustard, and wheat. So these are the medium salt tolerant crops. So low salt tolerant crops are pulses, peas, sunham, some grams like some red gram like that, and linseed. So these are the low salt tolerant crops, students. So you please remember. And another important management is we have to leach the entire field with a good quality of irrigation water. Actually, whenever you found a salt problem in any particular land, what should you do? You have to go for leaching with a good quality of irrigation water. Good quality of irrigation water means what should you do? Very first, you have to, first of all, in the very first day, you should release that good quality water in the field, and you have to make a round with your tractor, and after you give us some time, then we have to release that water to outside. Don't release that dissolve that water to other field. That will be that is not fair. So we should release that salt water with in outlet. We have to release in out of the agriculture field. Like that we have to do at least from 7 days once, 15 days once. You should do means definitely we will get rid of this salt problem. So these are the major practices for the management of salt saline soils. The sodic soils, students. Sodic soils, another name is called alkali soils. You know what it was? Now you say, what is alkali soils? Any idea? What is the meaning of alkali soils? Okay, no answer. Anyhow, alkali soils are nothing but these are the completely sodium dominated soils, students. In this type, it's the sodium absorption rate. Sodiums are very rare. They are very, the accumulation of sodium is very high in this type, and also due to the lack of calcium, and there is no any soluble calcium, the pH will be very high, and EC will be very less because the rest of the salts are very less. Only sodium was dominated. Actionable sodium percentage is very high, EC is less, and pH will be more. So these are the typical characteristics, and completely the physical structure of the soil was completely denatured. There is the physical structure was completely destroyed because of high sodium content in the soil. So sodium content, the sodium dominated soils are called the sodic soils. So what are those characteristics? This is what student, the ESP is more than 15 exchangeable sodium percentage. Yes, here sodium was very high, but it is the same to the reverse in saline soils. It was less than 15, but here it is more than 15. Here ECE is less than 4 decisiemens per meter, but there it is more than 4 decisiemens. pH in saturation paste extraction is more than 8.5, but there in saline soils it was less than 8.5, but it is more than 8.5. So students, some sodic salts may contain large quantity of soluble salts of saline salts also, and the EC will be more the distance. So those type of salts, sometimes you can see both the problems in one cell. So those type of salts are called saline sodic salts or saline alkali salts. In such type of conditions, you can see more EC decisiemens per meter. So if the conditions, both the problems are there, both the saline salts and sodic salt problem is there, definitely then your EC will be more than 4, your pH also will be more than 8.4. The conditions will be like that. So this is regarding the sodic salts. So what is the remedy for the sodic salts, sir? It's nothing but we have to go for gypsum application on it. So whenever you apply a gypsum, what will happen? The gypsum, the sodium will be replaced with the calcium. So this sodium sulfate will be dissolved and will be washed out from the land. This also we have to go for very distinct calculation. So you have to go for gypsum requirement. So whenever you found a sodic soil problem, definitely you have to go for a gypsum calculation. So definitely there is a different analytical methods are there for calculating gypsum methods. So you have to go. There is a buffer method is there, and there is a calcium bicarbonate method is there. So many methods based on the conditions of the soil, based on the locality. We can choose our own methods in that particular. So gypsum is the best recommendation for the sodic soils. And what are the tolerant crops, sir? So mostly, so for sodium tolerant are rice and sugar beet are highly tolerated with the sodic soils problem. And semi-tolerant are wheat, barley, besom, and sugarcane, bajra, cotton. You can see. And sensitive crops. What are the sodium sensitive crops? Are cowpea, gram, groundnut, mung bean, and also peas and maize. You can see. And mostly, this type of soils are mostly we can expect in aride soils and incepti soils. So and NT soils and what is also some extent we can expect this, but mostly this type of soils are highly observed only in arid soils, arid zone. Only in arid soils we can observe this type of soils. In desert soils, so desert soils are nothing. These are completely distributed in desert area. How much it will be? Around 2,90,000 hectares. Mostly you can see north and west part of India, and major part of is will be located in Rajasthan and some parts of Haryana and Punjab and northern part of Gujarat. You can expect. Rainfall was very less, students, in this type of soils, less than we can expect, less than 50 centimeters to 10 centimeters. So hardly you can see very less rainfall. The temperatures are very high throughout the year. So average soil temperature of 30 centimeters around 34 degrees Celsius. Maximum soil temperature will reach up to the 50 to 60 degrees Celsius has been recorded during summer months. So this is the reason up to, you can say, 50 to 60 degrees we can record in summer months. The soil depth up to 30 centimeters, we can say around 34 degrees Celsius. We can see the soil temperature. So these are the desert soil characteristics. What are the characteristics? So organic matter in desert soils, nothing will be there, only sand will be there. So the organic matter status was very less. Accumulation of lime at the concentration was very high. You can see the accumulation of lime was very high. That's why in Rajasthan that gypsum digging was very high, and often even lime, all these things often quite weakly developed. B horizon was very less. Presence of accumulation of alkaline earth, you can see, and the clay content was very less, students. Almost we can see low, around 2 to 8%. The pH of soil ranges from 8 to 8.8. So mostly the presence of sodium, due to the presence of sodium, what is happening? Soils are susceptible for the dispersion. The particles will disperse. There is no proper aggregates, and the soils are less permeable. So the water permeability is very less. So the soils are very less permeable, and there is no proper aggregation because of high accumulation of sodium content. So these are the desert soils. Mostly where you can see this one also, you can see aride soils, and few and some you can also expect in NT soils. So mostly this type of soil, this type of desert soils are mostly used for only grassland and pasture only. In some areas we can grow some action, hardly we can grow some bear and pomegranate we can grow. Up to only this type of a bear and pomegranate we can grow. Grassland pastures we can grow with some advantage. We can take some by growing some bear and pomegranate, we can get some sort of advantage. We can get some yield by growing these crops. This is regarding the desert soils. Contrast and management. What are those? Mostly you can say sand dunes, undulating sand plains, all these things will be there. These are very poor conditions, students. Water holding capacity was very less. Recollection loss of water is and receiving rainfall from which is very difficult. So nitrogen phosphorus conditions are very less, and management is, so we have to manage very well. We have to go for very cautious management is very needed in this desert soil. So there's a lot of problems because all full of sand dunes on undulating surface will be there. So naturally nitrogen condition was very less. Hardly we can grow, students, two crops we can grow. On once irrigation, the soil well managed means we can grow for up to two crops. That too with a very careful irrigation and management in this soil. We need a lot of management practices. So forest and hillsides is distributed around 55 to million hectares, around 18 percentage we can expect. We can expect up to 18% of geological area distributed in mostly Jammu Kashmir, Uttaranchal, Arunachal Pradesh, all the northeastern regions, and Kerala. Andamans and Nicobar Highlands we can expect it. And while the climatic conditions, altitude conditions, complete forest species we can grow. So there is a good kind of the soil profile is completely dependent on kind of topography and vegetation. Control the soil profile. So mostly type of topography, what is the condition of topography, and also vegetation. So these two characteristics will control the type of soil profile was developed. Mostly different soil what different type of forest are the brown forest and podzolic. Mostly in Himalayas you can see this type of brown forest means different soil forests. So brown forest means you can say podzolic, mostly you can see in Himalayas. Red and lateritic mostly in our area. Deccan Plateau you can expect. The Himalayas are also formed under the cool and cold climatic conditions, sedimentary conditions, so igneous metamorphic rocks. So all this type of we can expect. So forest soils, so where nothing is there, the name itself it explains. It's completely this type of soil soil development and profile is completely determined by the topography and vegetation condition only. This is regarding some sort of forest crops. So podzolic soils. So the soils are completely developed by the podzolization, which is completely opposite for the lateralization. Mostly the soils we can say around in Manila areas of Himachal Pradesh, and found in some Simla and Dalhousie, and some area which is accumulation of organic matter, some amorphous material you can see. These are also very very acidic conditions. Soils are characterized. What are the characteristics, students? Mostly you can see moderate acidity means we can say around 5 to 6 conditions. You can see it has moderately acidic conditions. Very slight acidic condition will be prevail, and high organic matter around 2 to 3.5 percentage. Moderately high, 20 to 30% of clay content you can see. Variable exchange capacity of generally 10 to 25 milli equivalents we can expect. CEC. In low base saturation, hardly you can expect. Base saturation is very less than 50%. Deficiency of phosphorus is very common because of iron, aluminum phosphates. Soils are highly where you can expect. We can either completely these podzels are completely observed in alpine soils, majorly in alpine soils. Later we can see alti soils and incepti soils. So these are the fosilization. Brown forest, as we have explained previously, these are developed on sandstone, students. Sandstone and limestone at the just, and colluvium under the subhumid regions. You can say mixture of pines and mixture of other vegetation brown forest. The major characteristic, students, neutral to acidic condition. The pH is condition around 6 to 7. You can see if there is any calcareous material, sandstone is there, you can expect up to 8. So organic matter content of surface is around 1 to 3%, and CEC is around 50 to 25 milliequivalents per 100 grams of soil, and base saturation is around 70 to 90%. So high biological activity will be there because there is a organic content is there. The soils are classified as incepty soils, mostly you can see, and moldy soils and NT soils you can expect. We can classify under these 3 type of horizons. So characteristics, mostly peaty soils. Peat means partial decomposite soil, organic matter accumulated soils. Around 15,000 hectares occur in humid climatic conditions, students. So mostly you can see some content of soluble salts will be there. And the saline peat salts termed as karai in the state of Kerala, state where they remain submerged in water during monsoon streams. So whenever the salt plus the salt, the saline water plus this peat is mixture means under water conditions, and during monsoon it's called Karai in state of Kerala condition. You can see this type of condition occur in Kerala state. Remember, students, so the condition is Karai means it is prevailing between when the peat and the saline was submerged under water. You can expect this condition. The major characteristic of these cells, almost black in color, abundant 20 to 30% of organic matter content. You can see an accumulation of aluminum phosphates will be the, and pH will be around 3 to 4. If there are sometimes we can expect very high, strong acidity 3.5 to 4. So this may also vary from so this all these pH conditions are completely varies from pH, varies on the organic matter decomposition, nitrification process, and also pyrite conditions. So when there is a pyrite conditions, or when the sulfur acid conditions are there, we can see around pH around 3 to 5.5. So this pyrite, this sulfur, whenever you can see pyrite, all these conditions, those soils conditions, students. So this low pH condition is combated with the decomposition of organic matter under anaerobic conditions where there is no nitrification. So this type of soils are called cat clays or acid sulfate soils. So where you can see pyrite is oxidizable and sulfur acid is formed, we can say around 3.5 to 4 conditions. So these type of soils are called the cat clays or acid sulfate soils. You will get a separate lecture based on all these things, separate lecture. In Kerala, these type of soils we can grow only paddy condition. Why, students? Because this pyrite, the sulfidic, it will be during submerged condition, it will be sulfidic, no problem. Because whenever this was exposed to the open air, what happened? The sulfidic will convert into sulfuric. So entire land will become distinctly acidic, and there will be foul, rotten egg smell will come from that field. You can smell some rotten egg smell, and it will be very, you can see some mottles, you can see some yellow color mottling, you can observe. So those soils are called cat clays. So acid sulfate soils are also called as cat clays. Remember, students, this is very important. And next, marshy soils are confident in depressed crack area. Whenever there is a depression in any area, you can see marshy soil. Those soils are called the marshy soils. When dried in most alluvial and coastal plains, we can see marshy soils. So under anaerobic condition, you can see some blue or grayish color soils in submarine under anaerobic. Whenever the submerged conditions are prevail, prolonged submerged conditions are there, in that type of soils you can say around bluish gray color you can expect it. So this may be due to the ferrous ion and varying amount of organic. Why this color? Why this marshy? All this color was coming because of varying amount of iron and organic matter condition. So due to this ferrous ion and organic matter condition, this blue color was developed. Mostly these marshy soils, due to the soils which are formed in the depressed area. In depressed, whenever the land is there in depressed area, it was accumulated, we can see this marshy soils. Where you can see in coastal regions of Odisha, you can see Sundarbans, you can see in other places of West Bengal, this marshy soils are, you can easily observe it. That's all for today, students. Thank you very much. This is about the regarding soils of India. Regarding that problematic soils, that saline and alkaline soils, we will discuss very in deep in coming classes. That's all for today. Thank you.